Here we have the robotic arm which has a fixed orange base at A and fixed length members AB and BC. Motors at A and B allow for rotational motion at the joints. Based on the given velocities and accelerations at each joint, we are interested in determining the velocity and acceleration of end C. So let's use the geometry of the situation to set up position equations for point C in terms of x and y, and then take 1 and 2 derivatives to find velocity equations and acceleration equations for the desired point. So if I write the position, x position of point C, xc as a function of time equals to a length AB, which is 3 cosine of theta A plus 2 cosine theta B. In other words, this is xc and this is yc as a function of time. Therefore, y sub point C as a function of time is going to be 3 sine theta A, which is 0 for the position shown, plus 2 sine theta B. So I have two position equations, and then I can take derivative with respect to time to find velocity, and if I take one more derivative I can find a relationship for acceleration. Therefore, the derivative of the top equation, x dot of point C, this is of course as a function of time. I leave t for simplicity out of the equation and write derivative of cosine of u is minus u prime sine of u. Therefore, this is going to give me minus 3 theta dot A sine theta A minus 2 theta dot B sine theta B. If I take a derivative of the y equation, I'll have y dot sub C equal to 3 theta dot A cosine of theta A plus 2 theta dot B cosine theta B. So these are the two equations for components of velocity of point C. Now if we write down the given information for the position shown, theta A is 0, theta dot A is 5 radians per second, theta double dot A is 0.2 radians per second squared, and for point B we have the following: theta B is minus 30 degrees, theta dot B is 3 radians per second, and theta double dot B is minus 2 radians per second. Now plugging in the given data will give us the following: x dot sub C is minus 3 sine 0, which is 0, and minus 2 sine of minus 30 degrees times 3, and simplifying this will give a value of 3 feet per second. Similarly, y dot sub c is going to be 3 cosine of 0 times theta dot a, which is 5, plus 2 times 3 times cosine of minus 30, and this gives a value of 20.2 feet per second. Therefore, velocity vector for point C will have these two components, 3 feet per second for x component and 20.2 feet per second for y component. If I write the two components of velocity equation, we had x dot c equal to minus 3 theta dot a sine theta a minus 2 theta dot b sine theta b, and then for y dot c we had 3 theta dot a cosine theta a plus 2 theta dot b cosine theta b. To get the acceleration equations, we take time derivative of each of these equations and write the following: x double dot c equals to, observe that the first term is a product, so I will have derivative of first times second plus first times derivative of second, so I have minus 3 times theta double dot a sine theta a plus theta dot a times derivative of sine of theta a, which is theta dot a cosine theta a. And then the second term is minus 2 times, again I have a product, so I have derivative of first, which is theta double dot b times second, plus first times derivative of sine of theta b, which is theta dot b cosine theta b. Now all of this is the x component of acceleration, which can be simplified as x double dot of c equal to, let's see, minus 3 theta double dot a sine theta a minus 3 theta dot a squared times cosine theta a, and then I have minus 2 theta double dot b sine of theta b minus 2 theta dot b squared cosine theta b. So this is the x component of acceleration. If I do a similar thing for the y component of acceleration by taking derivative of this equation, I will have the following: 3 times derivative of first is theta double dot a times cosine of theta a plus theta dot a times theta dot a times minus sine of theta A. And then I have for the second term plus 2 times theta double dot B cosine theta B plus theta dot B times theta dot B, derivative of cosine is minus sine of theta B. Simplifying and rewriting this will give us 3 theta double dot A cosine theta A minus 3 theta dot A squared sine of theta A plus 2 theta double dot B cosine of theta B minus 2 theta dot B squared sine of theta B. Such a beast. So these are the two components of acceleration. Next, we want to plug in the numerical values and get the final answer for acceleration of point C. After plugging in the numerical values and using a calculator, we'll find the x component of acceleration of C to be minus 88.59 feet per second squared, and for the y component of acceleration we'll get a y double dot C equal to 6.14 feet per second squared.